the title of this is Using Logarithms to Solve Exponential Equations. But if you're asked to solve something like this exponential equation, you don't need logarithms to do it, right? You can get a common base between 27 and 9. What would that common base be? 3. So change the 27 into a 3 cubed. And change the 9 into a 3 squared. And simplify using the exponent laws. So this becomes 3 to the power of 3x minus 12 equals 3 to the power of 2x plus 6. And then you can equate the exponents because the bases are the same, and it's simplified to just one power on each side. So we get 3x minus 12 equals 2x plus 6. And then solve for x. Subtract 2x from both sides, you're left with x over here. Add 12, and you have 18. So x equals 18. You already should know how to do that. So this is kind of the common base method. But if we look at a question like this, 7 to the power of 2x equals 2 to the power of x plus 3, there's a problem with using common bases, right? You can't get a common base between 7 and 2. That's when we need another method for solving. And that method is going to be using logarithms. So what we'll do is take logs of both sides of the equation. So just put a log in front of the whole thing. And it looks like this. Log 7 to the power of 2x equals log 2 to the power of x plus 3. You could use any base as long as you're using the same base for the log on both sides. So I use base 10 just because that's the most common one. That's what your calculator's set up to do evenly. I'm going to do a base 10 log. But you could just as well do a log base 2 or log base 3 or whatever. Just makes sense to do a base 10. So we take base 10 logs of both sides. And then we're going to use the laws of logarithms to simplify. The exponents can become coefficients. So this becomes 2x log 7 equals x plus 3 log 2. X log 7 equals x plus 3 log 2. And then the one on the right, I'm going to expand that further. So we'll go 2x log 7 equals x log 2 plus 3 log 2. That's not a law of logs or anything, that's just multiplying x times log 2 and 3 times log 2. We need to solve this for x. And so to do that, we want to get all the x's on one side of the equation and everything else on the other. So what we'll start with is subtracting that x log 2 from both sides. So here's subtract x log 2 and subtract x log 2, so that all the terms with an x in it are on one side and the terms without an x are on the other. 2x log 7 minus x log 2 equals 3 log 2. Now all of the x's are over here. But we need to isolate that x. Factor the x out. So take out the x from both of those terms. This becomes 2 log 7 minus log 2. And this 2 log 7 minus log 2 is just a number, right? That's all just a number, so we can divide by that number. And we end up with x equals 3 log 2 divided by 2 log 7 minus log 2, which we can then evaluate just using our calculator. So from there, when I punch it into my calculator, I get x equals 0.65 when I round it to 2 decimal places. Here's another one that I just, it's a little bit different because it has more things going on. So let's have a look at solving this one using logs. First, I'm still going to just take logs of both sides. So put a log in the front. The log of all that stuff equals log 5 to the power of x. In the previous question, the next step was we took those exponents down, but there's a problem with doing that on the left side. Do you know what the problem is? Yeah, it's because it's multiplied by 8. That 2 to the power of x is the exponent only on the 3, not on the 8. And so we can't take the 2x in the front until we deal with the fact that we have that multiplication. So we're going to use that law of logarithms that says that if you have, you usually use it the other way. When you're adding things together, you can make it into one logarithm by multiplying the arguments. We're kind of working backwards here. The arguments are multiplied. We're going to separate it into 2 logs. So it's going to be log 8 plus log 3 to the 2x. And now the exponents can turn into coefficients. Log 8 plus 2x log 3 equals the log of, equals, I want to do the same thing over here, x log 5. So exponents become coefficients. And now it's just the same process. Get all the terms with x's on one side, factor out the x, and then divide by the other factor. So I'll go log 8 equals x log 5 minus 2x log 3. So we subtracted that 2x log 3 term. Factor out the x, so that's log 5 minus 2 log 3, and then we can solve for x by dividing by the second factor. So log 8 divided by log 5 minus 2 log 3. And we'll just punch it into the calculator and see what we get. X equals negative 3.54. Now I want to look at solving logarithmic equations. So solving equations that have a logarithm in them to begin with, and the variable is in the argument of the log. If you think about the common basis method of solving exponential equations, and then you look at this logarithmic equation, you might be able to figure out fairly quickly how to solve this one. These 2 logarithms have a common base, and because you have just one logarithm on the left and one logarithm on the right, you can just equate the arguments. So cross out the log base 6, and you have 2x minus 1 equals 11. If log base 6 of 2x minus 1 equals log base 6 of 11, then 2x minus 1 must equal 11. And then just solve. Add 1 to both sides, and then divide by 2, and you get x equals 6. That's going to be our basic plan for solving logarithmic equations. is get them to the point where you can just equate the arguments. So just like with exponential equations when we were doing common base, you had to simplify using the exponent laws to the point where you had just one power on each side. We're going to do the same thing here. Simplify until we get something that looks like this, which is just one log on each side. So if we look at this one, we can't just equate the arguments because we have a logarithm on one side, but then an integer and a logarithm on the other. So we somehow have to simplify it to the point where we have just one logarithm on each side. And we're going to do base 10 logarithms because that's what we already have here. On the left, I already have just one logarithm, so I'm going to leave it like that. But I need to do something with this 2 minus log of 7x minus 1. I need to take that 2 and change it into a base 10 log. Sorry? Is it just log 2? No. I need a base 10 logarithm that equals 2. So log base 10 of something, and that has to equal 2 because I want to replace a 2 with it. But if we think of this, let's see, log base a of a to the power of b, what's that equal to? This is just equal to b, right?
Also log 10 of 10.
Right. So what that means is if I do log base 10 of 10 squared, that's equal to 2. So use the laws of logarithms now to combine those two logarithms into one. This side is still going to stay the same. This one becomes a log of 10 squared, which is 100, over 7x minus 1. Divide because they're subtracted. And now you have a base 10 log on both sides and nothing else, so we can equate the arguments. We can say that x plus 2 equals 100 over 7x minus 1. And then solve that. So we'll have x plus 2 times 7x minus 1 equals 100 when I go to solve that. Expand. And I just moved the 100 over. So we get 7x squared plus 13x minus 102 equals 0. So are we going to solve that by factoring? No? I think we are going to solve it by factoring, but you have other options, right? You could graph or use a quadratic formula, but I'm going to try this. The answers that we come up with, x equals negative 34 over 7, and x equals 3. We do need to look for extraneous solutions. Which would be negative 34 over 7. Why is that extraneous? I'm not saying that you're wrong, I'm just asking why.
I just know that 3 is right.
You just know that 3 is right? Did you graph it and find that 3 is right?
Yeah.
3 is right. You can check by filling them in to the original and see which one works. Maybe they both work, maybe only one works. But in this case, one thing to remember is you can't take the logarithm of a negative number. And because this negative 34/7 is smaller than negative 2, when you fill it in, you're going to be taking the logarithm of a negative number. And right away, when you put that in, log of negative 34/7 plus 2, it's going to give you an error on your calculator because it's undefined. You can't take the log of a negative number. So this one's extraneous, and that's the actual solution.